The next section of the textbook is converting from Ka to Kb or Kb to Ka. And the formula for that, which is given in the textbook or on the formula sheet, is Ka times Kb is equal to Kw. And then something else that and this is the same Kw we used in the last chapter. This is 1 times 10 to the minus 14th, which you have to know. Something else I want to cover is that pKa is a negative log of Ka. So let's do some problems like that. So the first one says that the Ka of acetic acid is 1.8 times 10 to the minus 5th. What is the Kb? Okay, so we're going to use the formula Kw is Ka times Kb. So 1 times 10 to the minus 14th is equal to 1.8 times 10 to the minus 5th times Kb. So I divide both sides by the 1 times 10 to the minus 15th. So 1 times 10 to the minus 14th divided by 1.8 times 10 to the minus 5th is equal to Kb. So Kb ends up being 5.6 times 10 to the minus 10th. Here's the problem with the pKa. Again, I used the same Kas from above, and now it wants to know what is the pKa. So pKa is the negative log of 1.8 times 10 to the minus 5th. So that ends up being 4.74. I want to point out, I didn't do it on the last slide, that if pKa is a negative log of Ka, then Ka is 10 to the negative pKa, just like the hydronium ion is negative 10 to the negative pH, hydroxide is 10 to the negative pOH. It's the same format because this P right here, just simply means negative log. So this is the inverse of that. And the last one for this is that the Kb of ethylamine is 4.7 times 10 to the minus 4th. What is the Ka of ethyl ammonium? So it becomes a different, you see here, these become ions as the Kb. Okay. Again, I'm going to use the formula Kw is Ka times Kb. So 1 times 10 to the minus 14th is Ka is what I'm looking for, times 4.7 times 10 to the minus 4th. So 1 times 10 to the minus 14th divided by 4.7 times 10 to the minus 4th is equal to Ka. So Ka ends up being 2.1 times 10 to the minus 11th. And that's how you convert between those two. So a lot of reference tables only give you values of Ka, so you have to find the Kb sometimes. Okay? That's the end of this video.